A physical quantity is a measurable property. What does this mean? Measuring implies a comparison between the observed value of a physical quantity and a certain amount used as reference, called unit. For example, here we can see two different units for distance, the centimeter and the inch. Note that they are different distances. The inch equals about 2.5 centimeters. Hence, a measurement may have a very different value depending on the units used to express it. For this reason, we must always tell which units we are using when providing the value of a physical quantity. Physical quantities can be of two kinds. Scalars, defined by just a measurement, a number and the corresponding unit. Mass, time, length, volume, or temperature are all scalar quantities. Or vectors, when in addition to the measurement value, the vector magnitude, it is necessary to indicate its direction and pointing. Examples of vector quantities are the velocity, the acceleration, or the force. We define and operate with vector quantities using vector algebra. A system of units is a sample of units, one for each physical quantity. There are some quantities considered fundamental. Their units, called fundamental units, are used to define the rest of units, known as derived units. The system of units most widely in use since 1960 is the International System, or aside from its name in French. These are the units of the fundamental quantities in this system. From these fundamental units, we define all the rest, taking advantage of the mathematical relations between the different physical quantities. For example, velocity is the change in position per unit time. Because position is measured in meters and time in seconds, its SI unit is the meter per second. Here you have some other examples of SI-derived units. Some of them have a proper name, usually that of some scientist. Another common system of units is the CGS system. The name stands from its fundamental units, the centimeter, the gram, and the second. A physical constant is a physical quantity such that, for a fixed unit system, remains unchanged over time in the physical processes. Some of the best-known constants are Planck's constant, the gravitational constant, or the speed of light in the vacuum. This table here displays some more.